200 pairs an hour. That's how many sneakers can roll off a single production line in a modern factory. One fresh pair hitting the conveyor belt every 18 seconds. But here's the thing, each one of those shoes is a masterpiece of precision engineering, robotics, and material science that would blow your mind if you saw it up close. Today, we're stepping inside the factories where Nike, Adidas, and New Balance turn raw materials into the kicks on your feet right now. Forget everything you think you know about how sneakers are made. We're not talking about rows of workers hand-stitching shoes anymore. Modern sneaker factories are part sci-fi laboratory, part high-tech assembly line, where giant robotic looms knit entire shoe uppers in minutes. Machines inject molten foam at 800 kilograms of pressure per square centimeter, and robotic arms apply adhesive with surgical precision. This is manufacturing at its absolute cutting edge. Let's start where every sneaker begins, with a single thread. The upper, where giant looms knit your shoe in one piece. Picture a machine the size of a small car, loaded with spools of colorful yarn, humming as it weaves your next pair of running shoes into existence. This isn't your grandmother's knitting machine. This is a CNC, computer numerical control, knitting machine, and it's creating what Nike calls fly knit and Adidas calls prime knit. Here's where it gets wild. Traditional shoe uppers require cutting dozens of separate fabric pieces, then stitching them together one by one. A typical sneaker might have 32 different components that need to be assembled in a precise sequence, but fly knit technology throws that entire process out the window. Instead, a computerized flat knitting machine creates the entire upper as a single, seamless piece of fabric. The machine is loaded with polyester, nylon, or spandex fibers, sometimes up to 10 different colors at once. The newest knitting machines can handle multiple fiber types simultaneously, mixing materials with different properties into the same upper. Want a stretchy mesh section for breathability over your toes? Done! Need reinforced support around the heel? The machine knits it denser. It's all controlled by computer software that tells each individual needle exactly when to knit, tuck, or skip. But here's the million-dollar question. How does a flat knitting machine create a three-dimensional shoe upper? The secret is in the shaping. Modern flat knitting machines can create what's called fully fashioned construction. They knit the shape directly into the fabric by adding or dropping stitches as they go. The upper comes off the machine already curved and contoured to fit the human foot with closed edges all around. No cutting required, no waste. The machine even weaves in support cables and reinforcement strips as it knits. These aren't added later, they're integrated directly into the fabric in real time. Watch one of these machines in action and you'll see the fabric literally growing before your eyes, layer by layer, row by row. The knitting head moves back and forth at speeds up to 1.6 meters per second, and depending on the complexity of the pattern, a single upper can be completed in anywhere from 30 minutes to a couple of hours. Once it's finished, the upper gets pulled off the machine, and unlike traditional cut-and-sew construction, there are almost no scraps left behind. The environmental impact? A fly knit upper reduces waste by about 60% compared to traditional methods. One machine, one piece, minimal waste. That's the future of shoe manufacturing. The sole injecting clouds of foam at 1,200 bar pressure. Now let's head to the other end of the factory where the magic of cushioning happens. If you've ever wondered why modern running shoes feel like walking on clouds, you're about to find out. It all starts with tiny white pellets of EVA, ethylene vinyl acetate, a foam material that's become the gold standard for sneaker midsoles. The process is called injection molding, and it's equal parts chemistry and precision engineering. Here's how it works. Those EVA pellets get loaded into a hopper and fed into a heated injection unit. The temperature inside that unit climbs to between 160 and 200 degrees Celsius, hot enough to melt the EVA into a semi-liquid state. Too hot and the material decomposes. Too cool and it won't flow properly. The temperature control has to be absolutely perfect. Once the EVA reaches the right consistency, it gets injected into a metal mold at pressures ranging from 600 to 800 kilograms per square centimeter. For perspective, that's roughly equivalent to the weight of a small car pressing down on every square centimeter of the mold. At some facilities, like the ones producing premium performance shoes, the pressure can reach as high as 1,200 bar. This extreme pressure forces the molten EVA into every tiny detail of the mold cavity, ensuring consistent density and perfect replication of the sole design. And here's where the science gets really cool. Mixed into those EVA pellets are two secret ingredients: a blowing agent and a cross-linking agent. When the molten EVA hits the heated mold, which is maintained at around 170 degrees Celsius, the blowing agent decomposes and releases gas bubbles. Think of it like baking a cake. The heat activates the leavening agent, creating air pockets throughout the material. But unlike a cake, we can't just let these bubbles expand randomly. The mold is designed to open rapidly at precisely the right moment, allowing the trapped gas bubbles to expand in a controlled way. As the sole ejects from the mold and hits the air, it literally puffs up, sometimes doubling in size. Meanwhile, that cross-linking agent is forming chemical bonds that stabilize the foam structure, locking those air bubbles in place and giving the sole its characteristic bounce and cushioning. The entire injection molding cycle takes about 20 minutes per piece. For popular sizes, factories will run multiple molds simultaneously. Otherwise, production would be painfully slow. The result? That bouncy white foam sole that cushions every step you take. Some manufacturers have taken this even further. Adidas developed Boost technology, which uses thermoplastic polyurethane pellets instead of EVA for even more energy return. New Balance has experimented with 3D printed resin soles called triple cell, but EVA injection molding remains the workhorse of the industry, combining performance, cost-effectiveness, and scalability. The glue, when robots apply adhesive better than humans ever could. Now comes one of the trickiest parts of shoe manufacturing, getting that upper and sole to stay together permanently. For decades, this was done entirely by hand. A worker would grab a bottle of adhesive and squeeze it around the perimeter of the sole, trying to apply an even bead of glue without smearing it everywhere. The results? Inconsistent at best, glue would end up in the wrong places. Too much in some spots, not enough in others. Enter the robots. Modern sneaker factories now use vision-guided robotic arms for glue application, and the precision is absolutely incredible. Here's how it works. As each sole arrives at the gluing station on a conveyor belt, a 3D vision camera scans it while it's still moving. The camera captures a point cloud, essentially a three-dimensional map of the sole's exact shape and position. This is crucial because not every sole is perfectly identical and they're not always oriented the same way on the belt. The vision system's algorithm processes that point cloud data in milliseconds, identifying the exact edges of the sole and calculating the optimal trajectory for glue application. It compensates for any irregularities in the sole shape or positioning. This trajectory gets converted into robot coordinates and transmitted to the robotic arms controller. No manual programming required. No skilled robot operator needed on the factory floor. After the robot applies glue to the sole, another robot, or sometimes the same one, does the identical process for the upper. Two precise glue paths, perfectly aligned, ready to bond. The oven, baking shoes to seal the deal. You might think the next step is just pressing the upper and sole together. Not so fast. That glue needs to be activated first, and that's where the heat comes in. The glued components travel down the assembly line on a conveyor belt into what looks like a giant industrial oven. This isn't about cooking the shoe. It's about activating the thermoplastic adhesive. These heat-activated adhesives remain dormant at room temperature, but when exposed to specific temperatures, they become incredibly tacky and form molecular bonds that are nearly impossible to break. The assembly line, orchestrating chaos into 200 pairs per hour. Now let's zoom out and see how all these processes come together. A modern sneaker assembly line is a carefully choreographed ballet of humans, machines, and conveyor belts. At New Balance's Lawrence, Massachusetts factory, every worker on the line spends an average of just 22.5 seconds on each shoe before passing it to the next station. That's not a typo, 22.5 seconds per worker per shoe. The 3 production lines running identical products in different sizes and colors, all moving in perfect synchronization. From the moment raw leather gets cut on the CNC cutting machine to the final lacing and quality inspection, each pair passes through a 55-step process involving 220 workers on a single shift. The conveyor belt is the unsung hero of this operation. Using stepless variable speed motors, the belt can be adjusted to match the pace of production, sometimes crawling along at a deliberate speed for complex stitching operations, other times zipping components from station to station. The belts are made from materials that can withstand high temperatures as they pass through drying ovens and heating chambers. In the fully automated speed factory concept that Adidas pioneered in Germany and Atlanta, the workforce was even smaller. Just 160 employees producing 500,000 pairs annually. That's over 3,000 pairs per worker per year. The robots handled the heavy lifting, laser cutting, precision gluing, heat bonding. Humans focused on quality control, machine operation, and the few tasks that still require human dexterity like lacing and final inspection. Here's what's mind-blowing. In traditional Asian factories, it can take 60 days to manufacture a shoe from start to finish, then another 60 days to ship it to Western markets. In a speed factory, the same process takes as little as a few hours. Every step is a minor miracle of modern manufacturing. Nike is one of the most recognized names in sportswear, and its shoes are known all over the world, not just for their style, but also for their performance and durability. Behind every pair of sneakers lies a fascinating and highly sophisticated manufacturing process that combines science, technology, human craftsmanship, and global logistics. From the very first sketches of a new model to the moment the shoe appears on shelves or arrives at your doorstep, there are countless steps and thousands of people involved. This is the story of how Nike shoes are made inside the factory, step by step, and why their creation is such a remarkable example of modern industrial design. It all begins with design. Before a factory even produces a single pair, Nike's team of designers and engineers work together to conceptualize the shoe. They think not just about aesthetics, but also about functionality, comfort, and innovation. Designers consider the needs of athletes and everyday wearers, combining elements of sports science with current fashion trends. The process starts with sketches on digital software where different shapes, sole patterns, and material combinations are tested virtually. Special attention is given to biomechanics, how the foot strikes the ground, how weight is distributed, and what materials can maximize energy return or reduce strain. This design phase can take months, and prototypes are often made using 3D printers so that engineers can hold and test a physical model before the shoe goes into mass production. Once a design is finalized, sourcing begins. Nike works with suppliers around the world to gather the materials that will become the shoe. This includes synthetic fabrics, genuine or vegan leather, rubber compounds, adhesives, foam, and advanced textiles such as fly knit. Sustainability has become an increasingly important part of the process, so factories now incorporate recycled polyester, environmentally friendly rubber, and other eco-conscious materials. Every material goes through rigorous testing to ensure it meets Nike's quality standards. Samples are stretched, compressed, bent, and exposed to heat and moisture to simulate years of wear in just a few days. Only after passing these durability and safety tests are the materials approved for use in the factory. The actual shoemaking process begins with cutting. Large sheets or rolls of fabric and leather arrive at the factory, and specialized machines cut out precise patterns for each part of the shoe. The cutting process has evolved tremendously thanks to computer-controlled lasers and automated presses, which can produce thousands of identical pieces quickly and with minimal waste. Human workers still play a crucial role in inspecting each cut piece for imperfections, ensuring only the highest quality parts move on to the next stage. After cutting, the pieces go through stitching or bonding. This is where the upper of the shoe, the part that wraps around the foot, takes shape. Skilled workers operate industrial sewing machines to stitch fabric, mesh, and reinforcement panels together. In the case of Nike Fly-Knit shoes, advanced knitting machines weave a single seamless piece of textile that forms the entire upper. This eliminates extra seams and reduces weight while also cutting down on waste. Every stitch is carefully placed to balance flexibility with support, ensuring the shoe holds up under stress without sacrificing comfort. Next comes the assembly of the midsole and outsole, arguably the most critical parts of a Nike shoe. The midsole is responsible for cushioning, while the outsole provides traction and durability. For midsoles, Nike often uses foam materials such as Phylon or polyurethane. In some models, iconic Nike Air units, transparent pockets filled with pressurized gas, are inserted into the midsole. These air units are manufactured separately in specialized facilities before being shipped to shoe factories. They're tested for strength and consistency, since they need to withstand thousands of foot strikes without losing their cushioning effect. The outsole, usually made of durable rubber, is molded into specific patterns that provide grip for running, basketball, soccer, or casual wear. Molds are heated and pressed into shape, and then the outsoles are cooled and trimmed. Engineers design these traction patterns with careful consideration of the sport the shoe is meant for. For example, basketball shoes have pivot points for quick turns, while running shoes prioritize forward grip and flexibility. When the upper, midsole, and outsole are ready, the lasting process begins. This is where the shoe really takes shape. A shoe last, essentially a foot-shaped mold, is used to give structure to the upper. Workers stretch the upper over the last and attach it temporarily, ensuring the shoe has the correct size, shape, and fit. Then the upper is glued or stitched to the midsole. This is one of the most precise steps, as even a small misalignment can affect comfort and durability. Adhesives are applied carefully, and heat or pressure is used to bond the pieces together. After bonding, the outsole is attached. Industrial presses apply heat and pressure to fuse the rubber sole to the midsole and upper. Workers check alignment carefully to ensure everything lines up correctly. Depending on the model, extra stitching or sidewall details may be added for reinforcement. The finished structure is now starting to look like a real Nike shoe, but it still goes through a series of finishing steps before it's complete. At this stage, additional components such as insoles, tongue padding, heel counters, and laces are added. Each of these has been designed and manufactured separately to match the shoe's specifications. Branding elements like the iconic Nike swoosh are carefully applied, sometimes stitched, sometimes heat-pressed, or even woven directly into the fabric in Fly-Knit models. Quality control inspectors check every detail, from the placement of the logo to the smoothness of the seams. Any shoe that doesn't meet Nike's strict standards is rejected or recycled. Once assembly is complete, shoes go through final quality testing. Workers flex the shoes, inspect stitching, measure weight, and check comfort. Advanced machines simulate running or jumping motions to ensure the shoes will perform as intended. Random pairs are even cut open to check the placement of air units or internal reinforcements. Nike's reputation depends on consistent quality, so this stage is taken extremely seriously. After passing inspection, shoes are cleaned, polished, and packed. Each pair is placed into a shoe box, complete with tissue paper and size labels. Boxes are then stacked into larger cartons for shipment. Nike's global logistics system then transports these cartons from factories, often located in countries like Vietnam, Indonesia, and China, to distribution centers around the world. From there, they are shipped to retail stores, online warehouses, or directly to customers who order through Nike's website. Behind this efficient process is a massive workforce. tens of thousands of people are employed in Nike's manufacturing supply chain, from engineers and designers to factory workers and logistics managers. Although automation has transformed many stages of production, human craftsmanship remains essential, particularly in stitching, quality inspection, and finishing details. Every pair of Nike shoes carries the imprint of dozens of hands that shaped, stitched, checked, and packed it. Nike has also invested heavily in sustainability initiatives. Factories are now required to reduce waste, recycle water, and cut carbon emissions. Programs like Nike Grind recycle leftover rubber and foam into new products, including playground surfaces and sports courts. Fly technology, by creating uppers from a single knitted piece, has reduced fabric waste by billions of pounds since its introduction. These efforts reflect Nike's growing recognition that the future of sportswear depends not only on performance and style, but also on protecting the planet. Nike shoes are more than just footwear. They represent innovation, global cooperation, and cultural impact. Each pair tells a story of design excellence, advanced materials, skilled labor, and precise engineering. When someone laces up a pair of Nikes, they're not just wearing a product, they're stepping into the result of years of research, testing, and craftsmanship. From the roar of the factory machines to the hands that tie the last knot, every step in the process contributes to making a shoe that inspires athletes and everyday wearers alike. And so, the journey of a Nike shoe from concept to completion is a remarkable one. What begins as a digital sketch on a designer's screen becomes a physical product worn by millions. Along the way, it passes through countless hands, machines, and tests, ensuring every pair meets the standards of comfort, performance, and style that have made Nike one of the most influential brands in the world. Whether on the basketball court, the running track, or the city street, each Nike shoe carries within it the invisible story of the factory floor where it was born. What makes Nike's factory process even more impressive is how it balances tradition with innovation. While highly automated machinery handles cutting, molding, and pressing, there's still a strong reliance on human skill and precision. A trained worker can spot a tiny flaw in stitching or alignment that no robot can yet detect. In many factories, you'll see rows of workers bent over their stations, guiding fabrics through powerful sewing machines with practiced movements. Some workers specialize in attaching swooshes or overlays, while others focus on applying adhesives or inspecting final products. Each station has its own rhythm, and together, the assembly line moves like a living organism, each part dependent on the other. Workers are trained extensively, because even a small error, like misplacing a panel by a few millimeters, could ruin the fit or look of a shoe. This training not only covers technical skills, but also safety, since factories are filled with heavy machinery, hot presses, and sharp tools. Nike has faced criticism in the past regarding factory conditions, which is why it now invests in improved safety standards, fair wages in many regions, and audits to ensure compliance with international labor practices. It's a reminder that behind every sleek pair of sneakers lies the labor of real people whose livelihoods depend on this global supply chain. Another fascinating dimension is Nike's focus on constant experimentation. Not every idea makes it to mass production, but hundreds of prototypes are created and tested each year. Some test new cushioning systems, others play with alternative materials like plant-based leather, while others are designed to maximize recyclability. Research labs connected to Nike's supply chain simulate extreme conditions: freezing temperatures, scorching heat, rain, mud, and repeated stress tests. Shoes are bent tens of thousands of times in machines that mimic running steps, or slammed against hard surfaces to see how long soles last. When you buy a pair of Nikes, you're wearing something that has survived brutal tests long before it ever touched your feet. Beyond performance, Nike factories are increasingly places where sustainability is engineered into every step. Traditional shoemaking creates a lot of waste: scraps of leather, leftover fabric, rubber offcuts. Instead of discarding them, Nike pioneered programs like Nike Grind, where these scraps are ground down and turned into new products. You might walk across a basketball court or playground surface made from recycled Nike shoe material. In factories using fly knit technology, waste is reduced by up to 60% compared to traditional cut-and-sew methods. And with new initiatives, some shoes are designed to be disassembled at the end of their life, making recycling easier and more efficient. Sustainability isn't just about waste, it's also about energy and water. Many Nike factories now run on renewable energy sources, and water recycling systems reduce the environmental footprint of production. It's part of Nike's broader commitment to move towards zero carbon and zero waste, which is ambitious but critical in today's climate-conscious world. Factories are the front lines of that battle, where every process can be reimagined to be cleaner and smarter. From a cultural perspective, Nike factories are not just producing shoes, they're producing icons. Think of Air Jordans, Air Max, or Nike Dunks. Each of these models had its origins in sketches, molds, and stitches on a factory floor. Workers may not always know the global impact of the shoes they assemble, but every time one of those pairs hits the shelves and sparks a frenzy of collectors or athletes, it's a testament to their work. Entire communities and subcultures have formed around Nike shoes, from basketball fans to sneakerheads, creating a cycle where the demand for innovation never ends. Logistics is another unseen yet vital aspect. After production, shoes must travel thousands of miles to reach consumers. Nike has built one of the most advanced distribution networks in the world, with massive warehouses equipped with robotics and AI systems that track inventory in real time. Planes, ships, and trucks carry shoes from factories in Asia to retail hubs across North America, Europe, and beyond. What looks like a simple purchase in a store is actually the final step of a complex global journey, one that began with design and ended with a shoebox in your hands. For consumers, it's easy to think of Nike only as a brand, a logo, or a style. But when you pull on a pair of Nikes, you're stepping into the result of years of expertise, careful planning, and international cooperation. Every layer of the shoe, the foam beneath your heel, the mesh around your toes, the rubber under your sole has been engineered, tested, and refined by countless hands and machines. That's why Nike shoes are more than just products. They're wearable technology, shaped by science and human creativity alike. And as the future unfolds, factories will continue to evolve. Already, we're seeing robots take on more tasks, AI predicting defects before they happen, and materials being developed that are lighter, stronger, and more sustainable. One day, you might be able to design your own pair online, and within days, a fully automated Nike micro factory near your city could produce and deliver them. The dream of mass customization, where every shoe is uniquely tailored but still affordable, is closer than ever thanks to advances in factory technology. The story of how Nike shoes are made in a factory is more than just an industrial process. It's a story of innovation, global teamwork, sustainability, and cultural influence. It shows how something as everyday as footwear can represent the peak of science and art combined. When you walk, run, or play in a pair of Nikes, you carry with you the hidden story of design studios, factory floors, and dedicated workers who made that moment possible. And so, as we close this journey through the Nike factory, take a moment to look at your own shoes. Think about the path they took, from a concept on a designer's computer screen to a finished product in your hands. Think about the workers who stitched the panels, the engineers who tested the cushioning, the machines that molded the soles, and the global network that delivered them to your door. Behind every step you take in your Nikes is a world of effort, passion, and precision. If this deep dive into the making of Nike shoes fascinated you, don't stop here. Explore more about the innovations shaping the future of footwear, the sustainability efforts that are redefining global manufacturing, and the people whose skill and dedication make it all possible. Science, machinery, and a little mystery blend together to create Spam. But forget what you think you know about canned meat. This is not a story about mystery meat in a tin. It's a cinematic journey through automation, innovation, and a magnified sense of tradition. Picture a race against time and bacteria, a perfect blend of old-school butchery and new-school robotics, where nothing is left to chance and every can carries a story. So buckle up. You're about to get an all-access pass inside the mega factory where millions of cans of SPAM are produced every single day. Picture Dawn, or breaking over a sprawling complex, trucks loaded with pork shoulder and select ham, their contents chilled and temperature monitored, rolling in just as the night shift finishes scrubbing every inch of the facility to hospital-grade cleanliness. No meat enters this temple of engineering until rigorous quality checks are completed. Each shipment is scanned, sampled, and signed off. The journey begins with the selection of only the best cuts. SPAM relies on premium pork shoulder for its soft yet firm texture, while the addition of ham brings a richness that's unmistakable in the final product. You may think all pork is created equal, but at this stage, even the smallest subpar detail means rejection. That's because making something as simple as SPAM requires 1,000 layers of discipline, know-how, and absolute precision. Once accepted, those perfectly marbled hunks of pork shoulder and ham are transferred into the chilled prepping area. This is where butchery transforms from craft to science. Gone are the days of blood-spattered aprons. Now, skilled staff and machines work together in a serenade of speed and exactitude. Advanced cutters and pneumatic tools separate bone from flesh, slice away unnecessary fat, and portion the meat into just the right sizes. Workers and AI-powered vision systems double-check every step. Even the trimmings have a home. Anything not destined for this batch might find itself in another Hormel product, part of the company's zero-waste philosophy. Next comes grinding, and if you're imagining a kitchen mincer, think bigger. Each batch weighs in at about 8,000 pounds. That's roughly the weight of 2 city cars, churned through massive industrial grinders engineered for consistency. These powerful machines break the meat down, mixing the fatty cuts with lean ones, creating a homogeneous pink paste. Consistency at this stage is key. Too coarse? The final product won't have that signature bounce. Too fine? You lose the meaty texture that made SPAM beloved in the first place. And with every batch, metal detectors scan for any foreign objects. Safety isn't just a policy, it's wired into every action. But safety and quality don't end with grinding. Here's where SPAM's secret weapon comes in: chilling and vacuum mixing. The freshly ground meat is mixed with crushed ice, instantly lowering the temperature. This ultra-cold environment does more than keep the batch fresh. It ensures the proteins won't break down or get rubbery during later processing. Inside the giant mixers, there's a literal vacuum, pulling all air out and further helping to prevent spoilage. This vacuum process is also crucial for another reason. It allows every particle of the mixture to bind together perfectly. So every slice of SPAM you eat is uniform from first bite to last. The benefits of vacuum mixing go beyond simple freshness and texture control. Removing air from the mixing chamber enables deeper seasoning penetration and keeps ingredient dispersal absolutely even, ensuring every portion tastes just as good as the next. This vacuum environment also aids in keeping colors bright and natural while locking in moisture, which leads to improved juiciness and shelf life. By reducing oxidation, the vacuum not only helps prevent discoloration and spoilage, but also intensifies the flavors and preserves the nutritional integrity throughout the product's long journey from factory to your table. All of this is achieved in a process faster than traditional techniques, minimizing processing time and maximizing quality. A perfect example of how technology and food science work together to create a global staple. Suddenly, the smell changes. It's time for seasoning and more science. Salt is added, not just for taste, but for preservation, ensuring no bacteria can survive. Sugar comes in to balance the saltiness, potato starch for that smooth, spreadable texture, a carefully measured splash of water to bind it all, and then sodium nitrite. This small but vital ingredient locks in the product's iconic pink hue and ensures that even after months on a shelf, the taste and safety endure. The exact blend of seasonings is closely guarded, part of the brand's DNA. Imagine the pressure in that control room, A single pinch off, and millions of cans could taste dull, salty, or, heaven forbid, not like SPAM at all. Meanwhile, technicians in spotless lab coats hover over sample lines, pulling shavings and spoonfuls from each batch. They run physical and chemical tests, checking color, pH, texture, and weight. If anything's off, computers alert the operation team, and the whole line pauses for troubleshooting. Efficiency counts, but perfection is the real factory law. All this, and you're only halfway to having a can in your hand. The now perfect meat mixture is whisked via ultra-clean stainless steel pipes toward the filling area, where automation takes over, ramping the process up to 90 cans filled per minute at peak operation. Each can is precisely aligned and filled, with cone-shaped nozzles injecting the measured portion in a single smooth motion. Sensors track fill weight and scan for air bubbles. Once filled, each can is vacuum sealed in a matter of milliseconds, sucking out every last trace of air before the lid clamps down. This vacuum seal is not just insurance against spoilage, it is the reason Spam's shelf life can stretch for years. Pause for a second and watch the ballet of machines as every can is stamped with key data. Production line ID, exact time of filling, and batch number. This level of traceability is key for food safety. If an issue is ever discovered, say with a single farm's meat shipment, every can can be traced instantly and withdrawn if needed. This is modern food security at its best, but the drama isn't over yet. The next phase might be the most crucial: thermal processing, or what workers call retort cooking. Sealed cans travel into cavernous, industrial-sized chambers called hydrostatic cookers, some large enough to fit a city bus. Here, they're exposed to a carefully calculated mix of steam and pressure, reaching more than 240 degrees Fahrenheit. The objective? Sterilization and perfection. The heat denatures meat proteins, shrinks and binds them, and kills any bacteria that could possibly remain. But it's a delicate balance: too hot or too long, and the meat dries out; too little, and the product is unsafe. Banks of sensors and computers track every variable, adjusting on the fly even for the smallest fluctuations. At the end of their steamy journey, the cans are rapidly cooled, zipped through showers and baths that bring them back to room temperature in minutes, a necessity to halt cooking and keep the texture just right. Now they fly down the conveyor to be inspected again and again, both by humans and machines. Each can is rotated, scanned for defects like dents or leaks, and checked for proper sealing. The label application process is next, and in true factory fashion, it's another hypnotic show. High-speed rollers gently wrap Spam's classic blue and yellow branding around each can with utter precision. Shrink-wrapped and coated, they're robotically stacked into boxes and immediately sorted for global shipment. Think the story ends as cans are packed for shipping? Think again, because the logistics of SPAM are nothing short of Herculean. Pallets are automatically loaded onto trucks or into containers, bound for supermarkets, corner shops, military bases, and even remote Pacific islands. That's right, Spam's enduring popularity is owed in large part to how reliably and efficiently these logistical juggernauts work. From rural convenience stores in America's Midwest to high-end restaurants in Seoul, Spam travels farther than most people do in a lifetime. And the scale is astonishing. Spam's distribution network spans over 40 countries, with cans crisscrossing oceans and continents thanks to multimodal transport systems that blend road, rail, sea, and air. Specialized warehouses handle thousands of pallets, tracking inventory movements with advanced logistics software that maps out optimal routes for rapid, cost-effective delivery. Supermarkets, local grocers, and even online retailers eagerly stock Spam for its long shelf life and universal appeal, making it a reliable choice for families, restaurant chefs, and emergency food supplies alike. Whether you're camping off-grid, preparing for a disaster, or plating up brunch in a city cafe, Spam's journey reflects a rare mastery of the global supply chain, a chain that never sleeps, constantly adapting to meet demand and keep this iconic food accessible across every corner of the world. And let's not forget, the magic of Spam isn't just what happens inside the mega factory. Once those cans arrive in homes, the ritual begins. A pop, a hiss, the twist and slide of that perfectly pink block onto the cutting board. Whole cookbooks are dedicated to this stuff. In Hawaii, slices are browned and layered atop rice, then wrapped in seaweed to make musubi, a local snack legend. In the Philippines, you'll find it alongside garlic rice and eggs, a breakfast feast with deep roots. South Korean kitchens prize it so highly, there's a gourmet variety that costs more than some cuts of steak. British chefs stuff it in fritters, and American chefs post SPAM burger hacks that rack up millions of views. In every corner of the globe, Spam transforms from humble can to culinary hero. Its story shaped as much by culture as by manufacturing. None of this would be possible without obsessive attention to quality and innovation. Every year, the factory upgrades its machinery, swapping older filling robots for new AI-enhanced models. Software gets smarter, predicting maintenance needs before breakdowns occur. Sustainability is always on the table. Any leftover trimmings are repurposed. Every drop of water in the cooling system is recycled. Solar panels and high-efficiency chillers keep the carbon footprint shrinking. Let's sneak back to the QA labs. Here, food scientists analyze cans from every batch, sometimes keeping archives for decades. Why? Because an off flavor found years after production offers a learning opportunity. Harmful bacteria and foodborne outbreaks are nearly impossible if processes are followed. But the factory's team never rests. They're constantly seeking ways to reduce sodium, test new spice blends, or even introduce limited edition flavors to global markets that now clamor for variety. In some markets, you'll find Spam with cheese, spicy peppers, teriyaki, or black pepper. Each gets its own run. Each as carefully manufactured as the classic. Let's zoom way out and marvel at the numbers. Every day, tens of thousands of cans roll off the line. In total, more than 8 billion since Spam's debut. That's more cans than people on Earth. The production is so relentless, the system so finely tuned, that a single ingredient truck arriving late could send ripples through supermarkets in 24 countries days later. But what really sets Spam apart isn't just the product, it's what it means to people. Spam was born out of necessity during the Great Depression, then earned its place as a lifeline in World War II, feeding troops and civilians alike when meat was scarce and shelf life was gold. It inspired generations of cooks, from parents prepping quick breakfasts to celebrity chefs who turn it into artful dishes. It became a symbol of resilience, ingenuity, and even rebellion. Across Asia, Spam became a delicacy after U.S. soldiers introduced it during war. In the Pacific, it's beloved at celebrations and on weeknight tables alike. Its durability made it a staple in disaster relief kits. Its unwavering quality made it the darling of home cooks, campers, and busy professionals in need of a reliable meal. So, next time you pass by that unassuming can in the supermarket, think about the technology, heart, and history crammed into every steel rectangle. From the vigilant eyes scrutinizing meat quality at 5 in the morning, to the engineers and food scientists running round-the-clock shifts to guarantee safety and consistency, to the designers dreaming up tomorrow's flavors and eco-friendly packaging improvements. It's a world within a world, hidden inside an ordinary object you can hold in your hand. What's left to discover? Maybe a new recipe, a memory from childhood, or just pure, simple comfort when you open a can on a rainy day. But one thing's for sure, Spam made in a mega factory isn't just a miracle of food engineering, it's a symbol of how collaboration, science, and tradition can keep breakfast, and plenty of other meals, going strong for generations to come. Next time you crack open that can, you'll know the extraordinary journey your Spam has taken. From carefully selected pork shoulders on the farm through a meticulously clean machinist's wonderland, sprinting past robotic arms and steam chambers, and all the way to your fork. Ready for a taste? Because there's a whole history packed into every bite, a story of innovation, global culture, and that unbeatable pink perfection, locked forever in the world's most reliable little can. Ready to see the incredible journey of SPAM for yourself? Visit the SPAM Museum in Austin, Minnesota for fun, interactive exhibits, and inspiring stories from around the world. Admission is free for everyone. Discover the legacy You probably know the drill. Hit the gym, crush your workout, scoop some protein powder, shake it up, and feel like you just leveled up. But have you ever stopped mid-shake and thought, wait, who actually made this stuff? Believe it or not, that smooth vanilla-scented powder didn't start in a lab or an Amazon warehouse. It started on a farm. Yep, the same place your morning milk comes from. The story of whey protein begins long before the gym mirror selfies. It starts with cows munching away in the sun. Picture the scene. Sunrise over rolling green fields, mist still hanging low, cows lazily chewing breakfast like they've got nowhere to be, which, to be fair, they don't. What they are doing is producing the foundation of one of the most popular supplements on Earth. That fresh milk is collected through automated systems and pumped straight into giant stainless steel tanks, basically milk fortresses on wheels. Inside, the temperature stays cold enough to make a penguin comfortable, keeping the milk fresh while it travels to the processing plant. Once it gets there, lab techs in white coats run tests on everything: fat content, protein balance, purity, you name it. If the milk flunks a single test, it's out. No second chances. The good batches go into storage tanks chilled to near freezing, waiting for pasteurization. That's when the milk takes a quick, super-controlled heat bath, hot enough to destroy bacteria, short enough to keep every nutrient intact. It's like giving milk a quick spa day. And then, the magic moment. A special enzyme is added, the milk thickens, and suddenly it starts to split in two. On one side, thick creamy curds, the beginnings of cheese. On the other, a golden, watery liquid, the stuff we used to throw away by the gallon. That's whey. For centuries it was just dairy waste. Farmers would dump it, feed it to pigs, or let it flow down drains. Then someone realized this so-called waste was packed with fast-absorbing, complete protein. What used to be a problem became the product. From here, the real transformation begins. At this stage, the whey is still in liquid form. Imagine a thin yellowish milk with a faintly sweet, almost bakery-like smell. It doesn't look like much yet, but this humble liquid is about to level up. It's pumped through a labyrinth of futuristic filters, an intricate network of membranes so fine they could make a coffee filter cry. These filters act like microscopic bouncers at an exclusive club, only letting the protein molecules through while blocking out unwanted guests like fats, sugars, and excess minerals. What comes out the other side is cleaner, leaner, and far more concentrated, the good stuff your muscles actually crave. This ultra-selective process is the reason your post-workout shake ends up being pure, efficient muscle fuel instead of a gloopy, milky soup. It's a little bit of science, a little bit of engineering, and a whole lot of quiet precision, all working behind the scenes to make that one scoop in your blender bottle hit just right. Once filtered, the whey heads to massive evaporators that remove most of the water without overheating the protein. It thickens into a golden concentrate that looks somewhere between syrup and molten caramel. You could taste it, but it wouldn't exactly scream dessert. Now comes the part that feels like straight-up sci-fi: spray drying. The thick whey concentrate is blasted through nozzles into huge chambers filled with hot air. In a split second, the liquid transforms into fine powder, like snowflakes forming in mid-air. The sound, the heat, the sight of clouds of protein swirling under bright lights, it's like watching chemistry and art have a baby. That powder is cooled, sifted, and polished until every grain looks identical. Then it's bagged in bulk, sometimes 20 kilos per sack, sometimes half a ton, and shipped off to flavoring facilities around the world. This is the point where science hands things over to creativity. Inside those flavoring plants, massive mixers spin like jet engines. Workers pour in the pure whey base, then add flavorings, natural sweeteners, vitamins, and minerals. Each blend has its own personality: chocolate that tastes like milkshake, strawberry that somehow tastes pink, and vanilla, the undisputed classic. Huge paddles churn the mixture until it's smooth enough to pass a spoon test. To make sure no ingredient rebels and floats to the top, the entire mix is spun in centrifuges, basically industrial blenders on steroids. 15 minutes later, everything inside is perfectly uniform. No clumps, no inconsistencies, no excuses. Then it's showtime. The tanks tilt and the mixture flows into an assembly line that looks straight out of a sci-fi movie. Containers roll under filling spouts, and robotic arms measure the powder to the exact gram. Too much? Rejected. Too little? Rejected. These machines don't do close enough. When each tub is sealed, it slides down the conveyor toward labeling, the final identity check. Bright labels snap into place. Barcodes and batch numbers get printed, and suddenly, what was once milk on a farm has become something with swagger, your favorite whey protein brand. The smell of vanilla and cocoa lingers in the air like a gym locker with better life choices. But here's the part most people never think about: the precision behind it all. Every scoop you take has been tested, weighed, tracked, and traced back to the exact batch of milk that started the process. There's a quiet army of food scientists and engineers making sure what ends up in your blender bottle is clean, safe, and exactly what it says on the label. And while most people see whey protein as just a fitness trend, it's also a sustainability success story. A byproduct once dumped by cheese factories is now one of the most consumed supplements on Earth, a shift that turned waste into wealth, both for the environment and the economy. Once those protein tubs are sealed and labeled, the operation kicks into overdrive. Conveyor belts hum like an assembly line symphony. Robots stack, scanners beep, and somewhere overhead a red light flashes as another batch hits perfection. From here, every container gets scanned, weighed again, and tracked with a digital ID, because one off-balance jar can mess up an entire shipment. It's a ballet of precision. Machines don't talk, but if they did, they'd probably sound smug. Yeah, we just filled 10,000 tubs before lunch. After inspection, the tubs are grouped by flavor: chocolate over here, vanilla over there, cookies and cream in the back. Like a protein family reunion. Workers pack them into boxes, slap on the destination codes, and before you can say macros, pallets start rolling toward loading docks. Some are headed to local gyms and supplement shops. Others are off to ports, airports, and freight hubs, beginning their second journey, this time across continents. It's kind of wild when you really think about it. Something that began as milk on a quiet little farm might end up in a locker room in Dubai, a kitchen counter in Tokyo, or a gym bag somewhere in Toronto. One scoop, powered by a global supply chain that connects continents, climates, and countless hands. But before those glossy tubs ever hit the shelves, there's one behind-the-scenes step almost no one talks about: shelf life testing. Every new formula batch goes through a miniature endurance challenge. It's exposed to humidity, heat, and time, all to see how well it holds up under real-world conditions. You could call it survival training for supplements. The powder's aroma, color, texture, and solubility are tested over and over to make sure that the very first scoop smells just as good and mixes just as smooth as the last one. It's quiet science ensuring your shake stays perfect, even months after you've forgotten when you bought it. And it's not just about longevity, it's about experience. Ever notice how some whey dissolves instantly in water while others clump up like wet sand? That smooth mix you take for granted is no accident. It's the result of hundreds of small tweaks, tweaking air temperature during drying, balancing fats for flow, even controlling static electricity in the mixing room. Yep, static. When you're dealing with powders this fine, one rogue spark can turn a factory into a snowstorm of vanilla dust. By the time it hits your hands, that tub of whey protein has passed through dozens of human checks and hundreds of automated sensors. It's chemistry, logistics, and obsession all rolled into one scoop. But here's the funny part. For all the tech and precision, it still comes down to something beautifully simple: milk. The same milk your grandparents poured over breakfast has become one of the world's most refined nutrition products. What used to feed calves now fuels humans chasing PRS at the gym, office warriors replacing lunch, or marathoners trying to recover before sunrise. The next time you crack open a fresh tub and that little puff of sweet, protein-scented powder hits your face, take a second to appreciate what's behind it. That scoop didn't just roll off a conveyor belt. It's the final act in a full-blown choreography of farmers growing the raw ingredients truck drivers hauling them across states, lab techs perfecting the formula, engineers keeping the machines humming, designers making the label pop, and, let's be real, a few caffeine-fueled interns making sure the numbers add up. It's a quiet symphony of effort and expertise. Thousands of people who might never step foot in your gym, but still play a part in your next PR, your recovery, your grind. Every scoop is their invisible high five to your hard work. And when that shiny tub finally lands on a store shelf, it's not just another product. It's the end of a story that began with sunlight on grass and a farmer waking up before dawn. It's billions of micro decisions, from which cows are fed what, to how long each droplet spends under heat, to how your label gets printed, all so that tomorrow morning when you twist off that lid and scoop your serving, it just works. Smooth, fast, reliable. No drama, no thought, just fuel. So yeah, your post-workout shake isn't just some random powder. It's engineering disguised as nutrition. It's nature and science working on the same team. And now you know the full journey, from pasture to protein, from cows to containers. The next time someone asks why whey protein is so expensive, tell them they're not just paying for powder. They're paying for precision, for innovation, for a supply chain that treats every gram like it matters. Because it does. If you found this breakdown as fascinating as that first sip after a brutal set, hit the like button. Stick around for more deep dives into how the everyday stuff we take for granted is actually engineered perfection. You lift the weights, we'll lift the curtain. See you in the next one.